So now we're moving on to the next step in factoring. Previously we used something called product sum. Now we're going to use something called product AC. The first step to product AC is I go ahead and multiply the term that's in front of the x squared times the final term. And technically these terms are called the A term and the C term, and the middle term is the B term. So if I multiply those together, I end up with 36. So what I'm trying to do is I'm trying to figure out a way of multiplying to make 36 and add to make 13. And if you play around with it a little bit, you'll see that it's got to be 9 and 4. Because 9 times 4 equals 36 and 9 plus 4 equals 13. So what I'm going to do is I'm going to rewrite this into an equivalent expression. So what I did was I broke apart the 13x into 9x and 4x. Because if I add them together, I can combine them. But I'm not doing that. This makes it easier to factor out. So what I'm now going to do is I'm going to look at these as different pairs. If I look at this, what is the greatest common factor of 6x squared and 9x? Well, that's going to be, I can take a 3 and an x out of both of them. If I do that, what I'm left with is, if I take 3x out of 6x squared, I'm left with 2x. If I take 3x out of 9x, I'm left with just plain old 3. So now what I'm going to do is I'm going to look at this pair here. I'm going to do the same thing. What's the greatest common factor that I can take out of both those? Well, I can take 2 out of both. If I take 2 out of 4x, I'm left with 2x. I'm left with 2 out of 6, I'm left with 3. So now you know you've done this right because I end up with 2x plus 3 in the two parentheses. So I'm going to go ahead and put that at the start. 2x plus 3. And then that's going to be times the stuff that's on the outside. And that's going to be my final factored answer. And if I multiplied this out by FOILing it, I'd see it was right. So here I've got a new problem. And if you notice, if I were to use the regular factoring method, I'd know immediately that this is going to be one of those ones that's going to be a positive and negative in the parentheses. That's going to be important for later. So what I'm going to do is I'm going to multiply this out. I'm going to end up with negative 20. So what multiplies to make negative 20, but adds to make negative 19? Well, it's going to be negative 20 times 1. So again, I'm going to break this apart. Start off with the beginning part, which is the same. That's going to be minus 20x plus 1x minus 5. So what's going to happen now is I'm going to pair these up again. What is the greatest common factor of 4x squared minus 20x? That's going to be 4x. So when I divide 4x into 4x squared, I'm just left with x. When I divide 4x into negative 20x, I'm just left with negative 5. And now I'm going to look at the second pair. Well, what do I have to factor out of 1x minus 5 to get to x minus 5? Because that's what I'm looking for. I'm looking for x minus 5. Well, there's nothing to factor out, so in that case, all I do is I factor out 1. I have to have something on the outside, because otherwise I can't use this method. So that's the reason why if there's nothing to put on the outside, you put a 1. So when I rewrite this, I'm left with now, for this here, 4x plus 1. And then for this part here, times x minus 5. If I multiply those together, I'll end up back where I started. And if I add them together, I'm going to end up with the 19 there as well. So in this one here, I should be able to recognize that the pattern, it's going to be a minus minus pattern when I actually do the parentheses expression. So I'm because of the subtraction in the second term and addition in the third term. So let's do this. What multiplies to make 9, but adds to make negative 10? And it's going to be negative and negative, so it's going to be negative 9 and negative 1. As those, when they add together, you make negative 10. So let's look here. When I rewrite this problem, it's going to be 3x squared minus 9x minus 1x. That's going to be plus 3. So now I'm going to look at these pairs again. What can I factor out of here? I can factor out 3x. When I factor out 3x, I'm going to be left with x minus 3. If I multiply that out, I'll end up back to that expression that's in the box. So now I have to figure out a way of making this into x minus 3. So in this case here, I want to change the signs of everything, but I don't want to change anything else. So I'm just going to factor out a negative 1. Because then if I multiply that by there, I'm going to end up back in the box there again. So my final answer is going to be 3x minus 1 and then x minus 3. That works if I move it up there and factor it again. So new problem here. Now I'm going to go ahead and look here. The pattern again is going to be minus, minus. I'm going to look for that at the end, make sure I've got that down, because I've got the subtraction sign right there and I've got the addition sign right there. So I know that that's the case. So now I'm going to rewrite this. I'm going to go ahead and multiply the 3 times the 40. That's going to give me 120. This might take a little bit more time to figure out, but 120, what multiplies to make 120, but adds to make it negative 29. So that took a little bit of practice, but I got to 5 and 24. So this is going to be the one I'm using here. So I'm going to rewrite this out now. So 3x squared, that's going to be here, minus 5x minus 24x plus 40. Okay, so now I'm going to look at these pairs again. What can I factor out of 3x squared minus 5x? The only thing I can factor out is going to be x. So I'm left with 3x minus 5. What can I factor out of this pair here? It's a bigger set of numbers. So I'm trying to make it into 3x minus 5. That's a big hint. So I know I'm going to have to factor out a negative because of that right there. I need to change that. So it's going to be a minus. And then I just need to figure out what to divide by. It's going to be 8. So then, I'm going to rewrite this out. X minus 8. And rewrite this out. And that's my final answer.